Good morning, hope everyone's had a good holiday. Now we're going to look at the second matrices lecture. Now what I want to do first is give you a little revision question to do. So what I've got matrix A, which is 4, negative 3, negative 5, 2. And matrix B, which is 2, 4, 6, negative 1, 3, 2. Right, and what I want you to do is find A times B and B times A. So what I want you to do is, I want you to pause the video here and attempt those two questions yourself. Okay, now let's go through the answers to these questions. So firstly, we want to look at AB. So that is 4, negative 3, negative 5, 2. And I'm multiplying that by 2, 4, 6, negative 1, 3, 2. Now, remember the crucial thing when we're dealing with matrices is we want to first write down the size of the matrix or the order of the matrix to make sure that we can multiply them. So, firstly, that's got 2 rows and 2 columns. So that's a 2 by 2 matrix. This here has got 2 rows and 3 columns. So that's a 2 by 3 matrix. Now that tells me the fact that the inside numbers are the same. That means that they can form and that they can be multiplied. Right, so what it also tells me is what my new matrix is going to look like. My new matrix, or my multiplying matrix, is going to be a 2 by 3. So I'm going to have 2 rows with 3 elements in each row. Right, that element there is row 1, column 1, because it's in the first row in the first column. This element here is row 1, column 2, and this element here is row 1, column 3. This is row 2, column 1, row 2, column 2, and row 2, column 3. Now, if you write that down, that tells you what row you're multiplying by what column. And remember, you're adding them together. So, I'm doing row 1 multiplied by column 1, and that's here. Right, so I do 4 multiplied by 2 plus negative 3 multiplied by negative 1. So that's 8 plus 3. This one here, we're then doing row 1 times column 2. So that's 4 times 4, which is 16, plus negative 3 multiplied by 3, which is negative 9. Then row 1 times column 3, so 4 times 6 is 24, plus negative 3 times 2 is negative 6. And notice I'm just putting my negatives in brackets. You could just go straight to a subtraction or a takeaway if you wanted. Right, it's up to you. I'm just writing down the full working so you see where it's coming from. Right, now we're doing row 2 times column 1. So negative 5 times 2 and 2 times negative 1. That gives me negative 10 plus negative 2. Then negative 20 plus 6. And then negative 30 plus 4. So hopefully you can see that. I know the setup, it kind of makes things not as clear, but it avoids us having to make, or avoids any mistakes. So all I'm going to do is I'm going to just work out each sum in a bracket. So 8 plus 3 is 11. 16 plus negative 9 is 7. 24 plus negative 6 is 18. Negative 10 take away negative 2 is negative 12. Negative 20 plus 6 is negative 14. And negative 30 plus 4 is negative 26. Okay, so that's the answer to the first one. So let's go and let's try BA. Right, so BA. Right, so we write BA as 2, 4, 6, negative 1, 3, 2. And A is 4, negative 3, negative 5, 2. Okay, so first thing we always do is we write down the order of the size of the matrix. So again, that's 2 rows and 3 columns. So that's a 2 by 3. This one here, 2 rows, 2 columns. So that makes that a 2 by 2 matrix. So you've got 2 rows, 3 columns, 2 rows, 2 columns. So remember, these inside numbers need to be the same. And they're not. So all we need to do is write does not conform. So B times A does not exist. Okay, there is no matrix BA. And you could easily be asked that in any sort of assessment at Advanced Higher or in Engineering Maths 4. They could ask you a matrix that doesn't conform, or they could ask you one that does conform. Now notice the thing about matrices. I've done A times B, and I've done B multiplied by A. In normal maths, they would be the same thing. But in matrix algebra, they are different things. AB, you can do. BA, we cannot. Okay, so let's go on to the first part of the next lecture. Okay, so we're going to be looking at determinants of matrices. Right, so now this is used later to calculate the inverse of a matrix. Now, the inverse of a matrix is the most important thing that we learn here, because effectively the inverse of a matrix allows us to divide matrices and solve matrix equations where you would normally think it would be a divide, but in fact you're going to be multiplying by the inverse. So again, this is just learning a process so that we can apply it later when we're looking to find the inverse of a matrix. Now, in this course, we only find the inverse of 2 by 2 and 3 by 3 matrices in this course. Right? And for a determinant to exist, the matrix must be square. So for a matrix to be square, remember that means it's got the same number of rows and columns. So that's why I've said 2 by 2 and 3 by 3. So you could find the determinant of a 4 by 4 matrix, 5 by 5 matrix, 6 by 6 matrix. But you can't find the determinant of a 2 by 3 or a 4 by 6 because it needs to have the same number of rows and columns. Right, so first of all, we're going to look at the method for a 2 by 2 matrix. Right. Okay, now, if A is our matrix A, B, C, D. Now we're going to be using this later on in the 3 by 3 matrix as well. So, to find the determinant of A, we call it det A. And when you're finding the determinant, the curly brackets become square brackets, like that. Or look more like absolute value symbols, but don't really think about it like that. Right, now, in order to find the determinant of a 2 by 2 matrix, you simply multiply AD and you take away BC. So it's A multiplied by D, take away B multiplied by C. So det A is AD, take away BC. Example 1. And crucially, if you're finding a determinant, the answer will always be a number or a value. It'll never be another matrix. If you get another matrix, you've done something really wrong. Okay, so if I want to find det A, so this is my matrix, 4, 7, 2, negative 5. I'll try and sharpen up that image in the camera a little bit. I think that's maybe a little bit better. Right, so det A means we put straight lines on either side. And it's just as simple as you would think. All we're doing is A times D, which is negative 20, take away B times C, which is 14. That tells me the determinant of A is just negative 34. Okay, now these are also known as finding the determinant of a minor matrix, because a minor matrix is made up of 4 elements if you're going from a 3 by 3 to a 2 by 2. But I'm going to show that next. Right, so I'm not going to do any more examples because it's straightforward. AD subtract BC. Simple as that. Now if you want, you can go and try and find some questions to do on 2 by 2 matrices, but I'd rather you just focused on what it is at hand. Right, okay, so this is 3 by 3 matrices. Right, so what we do is we expand along the top line three 2 by 2 matrices, not in the row or column of the corresponding element in the top line the 3 by 3 matrix. Right, so that sounds like a lot of words. So we expand along the top line, giving us or leaving us three 2 by 2 matrices, which are not in the row or the column of the corresponding element on that top line of the 3 by 3 matrix. Now, jargon, lots of words. Let's see what it means. So, find the determinant So let's just use this matrix here, A, and remember it's got to be square, so it's 3 by 3. So I'm going to put some negatives in it as well, just because that's normally what trips people up when we're doing this. Okay, so A is 4, 1, 2, 3, negative 1, 0, 1, 4, negative 2. Now we want to find the determinant, and as I've said to you before, the determinant is the first stage in finding the inverse. So this is just me going through it step by step. Right, so effectively the top line of a matrix has the following system of signs, right? And we'll come to this later, right? A matrix is made of a plus, negative, 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 plus. So that is how the elements are taken out of the matrix when we expand it, and we'll see that later when we expand across all rows of the matrix, right? So det A, so we want to expand across the top line, and this is my top line here, right? So the first element is positive, so it's positive 4, right? And we then create a 2 by 2 matrix, so if we look at this 4, of all the elements that are not on its row and not on its column. So that means I'm not using any of these elements, I'm not using any of these elements. So my matrix is negative 1, 0, 4, negative 2. Okay, then the matrix of signs tells me that when I expand across the top, that element there becomes negative. Okay, so it just changes the sign of it, right? And then again, I'm expanding this element here, so I don't want anything on its row or on its column. So the things that are not on that row and column are 3, 0, 1, negative 2. Then lastly, tell me it's positive, so plus 2. And we're multiplying again, not on its row and not on its column. Right, so that's 4. And again, all we're doing is AD take away BC. So negative 1 multiplied by negative 2 is 2. Take away 0 times 4, which is 0. Then take away 1, again, AD subtract BC. So 3 times negative 2 is, there we go, hopefully, right, so that gives me negative 6, take away 0, and lastly, again, AD take away BC, I've got 12, take away negative 1. Again, if you're doing this and you know you're taking away a negative number, you could just have written that as 12 plus 1. Doesn't bother me. It's up to you how you do it, right? So that's 4 times 2, take away 1 times negative 6, plus 2, and as I've said, that becomes a plus, multiplied by 13. So that's 8 plus 6 plus 26. You add those two numbers together, I get 40. Right, so we've expanded only across the top line. So we positive 4 to start off with, and this thing here is the minor matrix. And the minor matrix is the matrix that is not on the row and not on the column of the element on the top line. Same with here. That's 1. So not on that row, not on that column, give me 3, 0, 1, negative 2. Then lastly, this one here, 2, not on the row, not on the column, gave me 3, negative 1, 1, 4. And then I just did the process that I do for 2 by 2 matrices, because I've created a 2 by 2 matrix. Right, next. Example 2. So find the determinant of B. So B equals 3, negative 2, negative 4, 6, 3, 9, 4, 6, negative 2. Right, so again, I'm going to write out my matrix of signs. You don't need to, because it's always the same, but I'm just doing it so that just now we make sure we're doing it right. Okay, so det B. Now this is the crucial point to do with the matrix of signs and our original matrix. When we've got negative numbers on the top line and we're looking to expand along it, it can make it a little bit tricky in a way that it's easy to make a mistake. Now, just write down the sign. So that's going to be plus 3. Okay. And then my minor matrix, which is not on the row of 3 and not on the column of 3. So that's 3, 9, 6, negative 2. Right, and it's now a negative, so it's take away, and this element here is negative 2. Then the minor matrix at negative 2 is not on, so that's that one and that one. So that gives me 6, 9, 4, negative 2. And lastly, it's plus negative 4. And again, the elements are not on negative 4's row and not on negative 4's column. So that gives me 6, 3, 4, 6. Right, so that gives me 3. And remember, I'm just doing AD take away BC. You don't need to write that down. So that's negative 6 take away 54. Then your two negatives make a, or your two subtract signs come together and make it an add. And we're doing 6 multiplied by 2, which is negative 12, and 9 multiplied by 4, which is 36. And I've got 6 multiplied by 6, which is 36, take away, or subtract 4, take away 3, which is 12. So, work out that in the bracket gives me negative 60. Multiply that in the bracket gives me negative 48. And I work out that in the bracket and it gives me 24. So you just process those numbers, use a calculator, use your head, whatever you prefer. So 3 multiplied by negative 60 is negative 180, 2 multiplied by negative 40 is negative 96, and negative 4 multiplied by 24 is also negative 96. So we put all that together and it gives me negative 372. Right, I'm going to give you one to try. I'll give you the answer and then I'm going to direct you to ones in the book. So, in fact, I've just directed you to the ones in the book. So, what I want you to do is go to page 47 of the Matrices book, which is on Microsoft Teams. Again, if you don't have access to that, then I suppose I could put up some questions. So, right, so page 47, I want you to try question numbers 1 to 3. And again, the answers are at the back of that book, if you want to try it. Now, if you don't have access to those questions, for whatever reason, I'm going to give you these ones here. Hopefully you can see them. So, your matrix B there, matrix C, that's -1 there, and matrix D here. And if you want to try those questions, then the answer you should get for B is 33, the answer you should get for C is -21, and the answer you should get for D is 0. So if you want to try 3 extra questions, there's 3 extra questions there too. Right, now, just one last thing after you've done those questions on determinant. If the determinant of a matrix exists, it is called if the determinant of a matrix is 0, then the inverse doesn't exist. This matrix is singular. Okay, because it doesn't have an inverse singular. Right, so that's the determinant of so that's in revision, the determinant of a 2 by 2 matrix, the determinant of a 3 by 3 matrix. I want you to try the questions on page 47, questions 1 to 3, and also, if you've got time, those 3 questions that I've just put up on this on the page in front of you. So if you can please try that, I will put up the next lecture on actually finding the inverse of a 3 by 3 matrix and the uses of the determinant of a 3 by 3 matrix soon.